Hello and welcome to the eighth episode of programming course. At the last session, we have discussed the recursive function programming and we have written this Fibonacci recursive and the Fibonacci linear function. And let's forget about them. In this session, we are going to talk about recursive functions a bit more, and we are going to implement two functions which you are actually familiar with in the real life, because those are the power and the multiplication, two mathematic operators which you might use every often, and we are going to write their code both in the linear way and the recursive way. The linear name is not so common, so I'm going to use recursive functions and non-recursive functions from now on. Let's jump right in. Let's start with the multiplication function. The multiplication has been made of summation. For example, if you want to multiply 3 by for example 4, you can just write 3 4s and just add them together, and or vice versa. You could just write 4 3s and add them together, and now you can just get the result of this multiplication. In the our logic for the recursive function for the multiplication, I'm going to use this phenomenon. I'm sorry that I'm a bit slow because I'm trying to pre-write the code simultaneously in my mind, because I don't have any note written from before, and I just kind of I want to go with the flow. So imagine that you want to multiply 3 by 4, which we were writing this, and the AI is just suggesting some nonsense, and just ignore it. You can write this by 3 times 3 plus 3, and for the 3 times 3 you could just write I forgot the comments session. 3 times 2 plus 3 plus 3. This plus 3 from before was here. I just expanded this part to 3 times 2 plus 3, and these 3 just carried from the last session here. So let's try it one more time. 3 times 2 could be written by I'm going to open another parenthesis, 3 times 1 plus 3, and so on. So is it right? Is it right? This is right. And anything multiplied by 0, we know that is equal to 1, so 3 times 1 could be written by 3 times 0 plus 3, and anything multiplied by 0 is actually 0. I'm sorry, I said it's equal to 1, but it's equal to 0. So let's write this code. I'm going to name it mul. A and B is our input, and if B is 0, then that's the whole point. AI just spoiled that. God damn it, I forgot to turn this off. Let's see if we can disable it. It's snooze for 60 minutes. That sounds good. Damn AI. Yes, AIs are actually replacing us, so it replaced me. So, where were we? Yeah. If it's B equals to 0, then the response of this multiplication is 0, so we're gonna return 0 without any semicolon. Sorry, I have done a lot of PHP lately, so I can't help it with the parentheses and semicolon. Well, but the otherwise, yeah, if A was 0, then the answer is actually 0 again. What about other situation? Other situation, you could just write A times B minus 1 and plus A, just like here, A times B minus 1 plus A itself. Yeah, but this multiplication you could just replace it with the mul. So I'm going to write mul A and B minus 1, and the result, whatever it was, just added with A, and simply that's the result. That's a bit different with the one that AI has been suggested, but don't worry, it will work. That would work too, but it had some bugs. The codes that a human has been written is it's more valuable than an AI generated thingy. So let's test it and see if I were right or not. So let's multiply 3 and 4 by this way, and let's see the results. Yeah, it's 12 and quite working, not bad. What about 5 times 10? Would it be, I have to save it first. Yeah, it's 50. It's working like a charm, actually. Yeah. Let's write the nonlinear way. The nonlinear way, you could just my code actually has another problem. It cannot multiply negative numbers because it doesn't matter how many times you decrement a negative number, you never reach 0. So the algorithm never ends, and the recursive tree goes all the way as long as your memory can handle it, and at the end, when your memory is full, your cache is full, your disk is full, it's just going to crash everything, and the OSs are not allowing that, and they just going to mark your app as not responding. Your app kind of freezes. So let's ignore it for now for the negative number, because that's another episode, I believe, and it has some difficulties. We're not going to waste our time there. We just want to learn what is recursive function programming, and that's it for now. So let's write another function for the power. I said, yeah, the power. So I don't have in normal keyboards there's nothing that you can represent power with except this caret thingy. For example, if you want to say to the power of 3, you could just write this. So I'm going to use this caret 2 because you cannot write a number in a small symbol at the top right corner of another number and show that this is the power so the caret it is. So any number to the power of any other number in this situation, or in this example we can say to the power of 3, could be written by 2 to the power of 2 times 2, right? Because the single 2 is actually to the power of 1, and if you just multiply two powered numbers, the powers are going to be just add up if the base are the same. In this case, bases are 2, so the powers going to add up to 3, which it was from before. I'm not going to explain the fundamental part of why this works or things like that. So for the 2 times 2, I could just say 2 excuse me, to the power of 2. I told 2 times 2, yeah, that was right. To the power of 1 times 2 and another times 2 from before, just carried away. And if we go all the way, which is just another level inside, to the power of 0 times 2, and anything to the power of 0 is actually equal to 1 by the definition. So let's write that too. I'm going to call it POW, which is an abbreviation for power, and any number to the power of anything, in this case a to the power of b, we say we cannot check for this other thingy because 0 base is not equal to 1. So if a was 0, then our answer is actually 0, because 0 to the power of anything is 0. But if b was 0, then the result is actually 1, because any number to the power of 0 is equal to 1 by the definition. So and at the any other situation, you could just write a to the power of b minus 1 times a itself, but a to the power of anything could be written by power of a and anything that we want, which in this case is b minus 1. So let's test this out and print power 2 and 3, which we are expecting to be 8 and 3 to the power of let's do to the power of 10, which is 124, the famous kilobyte. Let's see, yeah, 8 and 124. This is working very fine, very easy. And for showing the nonlinear solutions, I'm going to write each one a nonlinear solution too. So let's start with the multiplication non-recursive, which I add the nr postfix for this, for a times b. I'm going to define a sum which has 1 for initial value, because 1 is effectless, I believe. It won't affect the multiplication value. You can add any number of 1 to the multiplication you want. It won't change anything. For example, if you had 2 times 4 times 6, you could just add a bunch of times 1 times 1 times 1, and it won't actually affect the and the final answer. So I'm going to assume that sum is 1 from before, and what and for I in a range of 1 all the way up to a itself, I want a itself, so a plus 1, just multiply sum by I, and assign it to sign, so it just simply updates the sum. You could just replace this with the sum times equal to I. Those are actually the same thing, but the bottom line is a bit more simple, shorter. It's an abbreviation, you can use it. So when the for loop is complete, you have the result. So let's actually suppress this, just comment those, and let's test the multiplication non-recursive. So print multiplication non-recursive by 3 and 4 and 5 and 10. I believe that was our latest example. So something is not working. Times 1 is actually ridiculous. Start from 2. Where is A? Yeah, that is it. Where is B? So this is absolutely wrong, because I've missed something. If you want to expand the multiplication by a bunch of addition, you have 3 addition because your base was 3. And otherwise, if you imagine that 4 is your base number, if you want to multiply 4 by any number, you could just write that number 4 times, not the 0 to the 4. You have to multiply by the number. So in range of A, just multiply sum by B, not the I. That was my mistake. Let's replace. Yeah. So 3 times 4, it's 13, and it just shows 1 unit up. It must be 12 and 50, not the 13 and 51. So there is a +1 somewhere, but where? I'm just adding that. Let's multiplication. That's a bit ridiculous. Come on. What? Oh, I'm just wasted. The sum is 1, but it must be 0, because what? Because the inert element in summation is 0, but in multiplication is 1. We are not multiplying this, we have to sum this, because we are turning the multiplication to summation. We have to do an addition, and in addition the inert element is 0. You can add a lot of zeros and it won't affect the answer. That was funny. So even pros can. I'm not pro, am I? Considering 8 years of programming, I could be pro. Even pros are mistaking, and I'm not cutting this out from this video, so you could see that anyone could have a dumb mistake. I had to know from there that there is 1 unit extra. So let's try it again, and yeah, 12 and 50 working like a charm. And let's let's do something more funny. So we have this multiplication here, right? We can just replace it with our multiplication, and it works because it's a multiplication. So 8 and 124, as we expected. That was a funny thing to do. Even you could use the non-recursive way, and it will be the same, because they are just multiplying 2 numbers. It doesn't matter what algorithm are you using. Actually, algorithm, it does matter, but it doesn't that much matter. It doesn't matter that much at this point, at least. Uh, Actually, I'm not trying to be. Uh, I'm not teaching you the advanced method of programming because uh, I'm just imagining this course is for elementary learners, and I try to explain things as simple as possible. So uh, let's write a linear solution for the power. So uh, as I have already explained, the inert element in multiplication is 1. So uh, we are going to use 1 as our initial value for sum. So sum is equal to 1 as um, it's, that's a issue with mine that I'm trying to pre-write any code simultaneously that I'm talking about them in my mind, and this causes some problems, some funny ones actually that has happened here. So uh, we imagine that sum is 1 at the start of this code, and let's just multiply a by itself b times. So for anything in range of b, just add a, don't add, just multiply a, multiply sum by a. Yeah, I'm not doing that again. So return sum. I just did. Come on. Power non-recursive 2 and 3. I'm going to input the same numbers and see if I get the same result. Yep, I got the same result. I think that's a success. And this is the nonlinear, this is the linear one. Come on, this is a recursive function, and this is a non-recursive solution for the power of two numbers and for the multiplication. You kind of know the job we have done here. So we have them, they are both working, and I wanted to show you this. Anything to the power of 0 is still 1, because if you haven't seen that, let's just zoom in a bit. This is to the power of 0 and the answer is 1. Because range 0 means never in Python, because it starts from 0 and it goes all the way up to 0, because the 0 is itself, and so the range is empty. The for loop never runs, and it never triggers. So the sum is what it was from before, and it is 1. So anything to the power of 0 is still 1. So our code kind of works, although it's not working for negative numbers. For example, actually I think the nonlinear one works for the negative bases. Yeah, that works, but that should be -8. Yeah, actually the power is working because the multiplication, this little multiplication here, and if we just replace this multiplication with our recursive one, it wouldn't work, because our multiplication, which we have written here for it won't work for the negative numbers, because it doesn't matter how many times you decrement a negative number, it won't ever reach 0. So we have no answer for the negative multiplication by this method, and for the other method the response is always 0, because range of minus numbers is the negative numbers. This is empty, and the for loop never trigger. So the answer is whatever the sum was, which it was 0 from the start. And if we replace this multiplication with our own multiplication, it won't work. But as long as we use this standard operand which the Python provides, it will work. And the power works for the negative bases, but not the negative numbers. Yeah, it just says 1, but this is not 1, you know. This would be what? This would be 1 over minus 8. The result of this should be, oh come on, what is this? The result of this should be 1 over minus 8, but our code just says 1, which is wrong because we are not prepared for the negative powers yet. So that was this episode that I was wondering to record, and I just did it at the latest time. Doesn't matter what time is it. So without any further explanation, see you later.